Fine-tuning OpenAI models used to feel like launching a rocket, super complex and daunting. But today, I'm going to show you a ridiculously easy way to fine-tune custom models in minutes with zero code. If you've never heard of fine-tuning, think of it as giving a model a PhD in a specific area instead of just having a master's degree in everything. We're going to use ChatGPT to generate all of your training data. All you have to do is upload all the files you need, and then you can try to synthesize your brand voice, the way your company responds to customer inquiries, or any other use case that's on your wish list. I'm going to walk you through two different methods to implement this. One is super easy, and the second is more hands-on with n8n, but it will make it much more effective and comprehensive. In the first method, all you'll have to do is upload the file we generate in ChatGPT and start training right away and test out the new model in your own playground. For the second method, we're going to be using a combination of n8n with Airtable to be able to actually monitor the training in real time, see the outputs, and quickly test whether or not your training has actually made a difference. By the end of this video, my goal is that you think that fine-tuning is no longer super complex and that anyone can use it if you just follow all the steps I'm going to walk through in this video. Let's dive right in. Alright, so for the very first method, what we do is we just take a prompt that I've put together and engineered over a few days that you'll have access to in the description below, so you don't have to worry about copy-pasting this. You can just look and observe. It is pretty meaty, and we'll go through it line by line, but pretty much we take this prompt and we paste it into GPT. We upload whatever PDF you need up here, and then pretty much what it will do is generate this very long file. And this is called JSONL, not JSON, JSONL. The main difference between JSON and JSONL is JSONL has examples, or in this case, every single component on one individual line. So imagine you had one line of JSON and you did a hard enter over and over again. I'm simplifying it, but pretty much this is a whole file that if you scroll to the right, has a series of examples. Let's say a prompt that you'd want to ask GPT and the type of answer you'd want returned back from the agent. This is how we're going to quote unquote fine tune and basically take a model like 3.5 Turbo, 4.0 or 4.0 Mini and tweak it so that out of the box, it talks a certain way without us having to do any prompt engineering whatsoever. Once we have this file, we'll just have to copy it here, paste it in a text file, and call the file something.jsonl, and then now we'll have something that we can go into the OpenAI Playground, create a brand new training session. We'll click on any model we want to fine tune. So in this case, let's say we take 4.0 Mini, and then all you have to do is upload the JSONL file that ChatGPT created, which is going to be in here, fine-tuning demo. We take demo, and then as soon as you click create, it's going to start fine-tuning the model. Now there are all kinds of small parameters here to be aware of, which is why I'm showing you how it works very high level before we go into a quick round of theory to explain what fine-tuning is, how it works on the ground, because whether you're technical or not technical, if you understand this concept, you'll have learned tons of deep learning concepts without having to get into the nitty-gritty of the math and all the mess that's associated with that. In the meantime, you can see here that it's going to validate our training file that we just took from GPT. It should work perfectly fine because O3 Mini High specifically is exceptional at creating JSONL files compared to previous models before, which is why using this use case with models wasn't as viable because one, the context window wasn't as large, and the output capacity of these models was also not as large. When you and I take a look at something like this, it might not look like much, but in terms of actual generated tokens, it's quite a bit. Now, while you need a minimum of 10 examples to quote unquote fine tune a model, the more typically the better, let's say between 50 examples and 70. So if you get to 75, 80 examples, at that point you have a very large JSONL file. So you need something like O3 Mini High in ChatGPT, or you could use Claude 3.7 Sonnet if you were a Claude person to be able to generate that file. Now, if we go back to the fine tuning, you'll see here that the files were validated, which basically tells us that we have the green light that it's in the right structure. Typically, when I used to do this a year ago, it would be a lot of back and forth. You'd have these small, tiny errors in your JSONL files. Maybe it's a syntax error, or you missed having the right line, and it was a bit of a headache to actually set up. But with this way, it's validated, and within usually 10 to 15 minutes, depending on the size of your data, you'll be able to have a fine-tuned model at your fingertips. Now the model has started fine-tuning finally, and I'm just gonna pause the video here until it's done just to show you what the output looks like. All right, and you can see here it took around 5 minutes, and it's pretty much almost done fine-tuning. It's creating this graph called training loss, and if you have no idea what that means, along with epochs, batch size, LR multiplier, I'll explain that in layman's terms in a second, but it's going to finish fine-tuning any moment, and once it does, it'll create this new ID for this model. This ID we can actually call from OpenAI in the Playground itself, or as you'll see later on, we'll be able to chat with it instantly into something like n8n, where you basically have a mini fine-tuned chatbot of your own at your fingertips. Now, it took a few more minutes to finish completely training, and now we have a brand new model that's called this. And you'll notice that it has a brand new suffix after my organization name. And what I can do now is go to my Playground, into chat, and then I can actually go into my model. And if I look up by the end of this model, the suffix here, you'll see I have a brand new model that I can speak to. And in my case, I was extracting some brand voice for this example. So if you have a random question, you can start asking back and forth. Write me a full story about AI taking over the world. Right, and you can send that over. And then you'll start having a back and forth with a slightly different model than you typically have with GPT-4o, because now it's had a chance to become a PhD in your specific area of choice. So while this is usable and useful, there is an easy way to do this. But before we even get to the theory and how you can configure what I just showed you to make it work and go back and forth until you have the perfect fine-tuned model, I want to walk through the prompt I showed you originally step by step so you know what is happening and how you can actually configure it yourself. So if we go back to the general Google Doc here, you'll see that we have an objective, which is generate a training data set for a fine-tuning chat model on target task. The reason why I'm referencing this target task here is just so that I can be lazy at the very bottom of my prompt and I can just enter what the task is. So I can say, I want to take these documents, let's say one PDF full of emails I've written before, or one example of a brief I've written before, and I want you to extract my voice and create a bunch of fictitious examples that we can use to fine-tune a model. In this case, it makes it a lot easier to configure this moving forward. And then the next thing I say is for the dataset requirements, provide 50 examples in JSONL format. Again, if you use something like GPT-4o or 4o mini, or even o1 mini, it might struggle with this, especially if they're very large examples, but o3 mini high or o3 mini are solid, and I believe also o1 should be able to be handling most of these scenarios pretty well. Next is I ask it myself to generate 5 test prompt examples. Now, you didn't see this in my original sample, but if we go back to the chat, I basically asked it to create some prompts that would help me test whether or not there's a real market difference in the new fine-tuned model versus the normal GPT-4o. So this is the manual way I'm doing this, and again, this is something I try to take care of in n8n hands-off. If you go back to the prompt here, we now give it an example. So I'm now feeding it what the JSON should look like. So user request and target task, and then ideal response in the same target task. So I got a lot of this knowledge from reading the documentation on fine-tuning, so you don't have to do that necessarily. You can just rely and lean on this prompt. And next I say, here's an example of a training scenario. I noticed in the documentation that if you want to tune a model, you want to ideally provide it structure in this format where you have a role and you say this is the system and this is the content that you want to send, and then this is the content that you want to receive back from the assistant in terms of response. So you're showing it good example, and this is what you should learn from this case and this case, and the more use cases you provide, especially depending on your task, let's say it's we want to respond to all kinds of inquiries using a chatbot, using our own fine-tuned model. Now you could technically do that by providing it maybe a few different PDFs of different transcripts of customer inquiries and back and forths, and have it learn and create examples out of those PDFs. Now again, you don't have to use 50, you could do 40, you could do 30, and you could do 75. I believe you could do up to 100 examples, but typically the sweet spot is, from what we tested, is 50 to 75 examples. And if you go to additional guidelines, here I break down, depending on the task we ask for in target task, create examples along these lines. So it could be Facebook posts, Instagram posts, emails, completely depending on, are we even replicating a brand voice, or are we trying to basically fine tune on a completely different thing? If it is, it'll be smart enough to know that it should just create examples that will help the model learn easier. And the last thing is I just ask it to output in a code block. So you can go from here to copying, to just opening some form of text editor, pasting it right here, and then on a Mac, I'll just put this into plain text, and then I'll save this as a fine-tune.jsonl. Again, very important you put L here, otherwise you're going to have some problems and it will not be validated by OpenAI. If we uncheck this and save, if we go back to our folder here, you'll see now we have fine-tune and it's in a JSONL format. If we just do get info, you'll see here, kind JSONL, and this should be fair game to use with the OpenAI Playground. And that's how you do method 1. Before we move on to method 2, it's important that we just level set on some of these details here, because maybe my example worked perfectly fine and you see some graph here doing something, but it's really important to understand what these are so you know how to actually change things or iterate on them if you're not getting good results. So I'm going to quickly shift to some slides to break down these concepts as simple as possible before we go on to method 2. So in general, fine-tuning again is as if you have this model, which could be GPT-4o, 3.5 Turbo, 4o Mini, you name it. You can even also fine-tune open source models, but that's not something I'll cover in this video. And then these models have a master's degree in all kinds of areas, whether it be writing, reading, creating content, creating newsletters, you name it. But fine-tuning is taking this knowledge and selecting one specific area, let's say the way that the LLM writes copy, and it gives it a PhD. And us creating all those examples we're feeding into the fine-tuning is us putting it through that PhD program to learn your style as quickly as possible. Now, when you upload PDFs to ChatGPT or Claude, let's say, and you tell it, hey, make.jsonl file, all we're doing is going from text or PDF or a doc to this JSONL file that has all those extra indentations. Once we have that, we now worry about training, and we call these epochs. So you can think of them as different rounds in a boxing match. The more epochs you train, the more times you show the model all of your examples over and over again. So if you only do one epoch, then you give only one opportunity for the fine-tuning process to see all your examples of sample prompt and your ideal output. Ideally, and by default, OpenAI does it for 3 different epochs. So it basically goes through the training data 3 different times to familiarize and synthesize what's in the underlying training file. Now you might think that if you train for 7 epochs or 10 epochs, that it will get that much smarter at understanding your style. But what actually happens is that it starts to memorize these training examples instead of generalize, which is a big deal. Because if it memorizes them, that means if you ask it for a task or a prompt that is way off your training examples, it won't know what to do with it. And if anything, it'll default back to the GPT-4o example. If it learns to generalize, it can be a lot more nimble. It will understand your style instead of memorizing the cheat sheet of FAQs you gave it. So that's epochs. If we move on to another parameter, batches, we're going to create a different analogy for this one. It's going to be a basketball analogy, and we'll carry it through for a few different slides. So imagine you're on a basketball court, and you're trying to become at least somewhat mediocre, and you're beginning from scratch. With every shot you take, you can either completely change your form or just slightly adjust it every few shots when you see something's not working. In the same vein, when it comes to batches, if you choose a batch of 1, that means that every single time you miss a shot, you try to adjust your form, versus just taking a couple shots with the same form and then checking whether or not you should adjust it. So small batches lead to more reactive changing in the weights of the model, so that every single time it sees a new example and it doesn't correctly identify how it should respond based on your example, it says, okay, let's adjust the weights just a tad every single time. If you want it to be less reactive, then you make your batch size bigger. So you won't change your form, or in this case, your weights of the model. Every different example you get wrong or not as good as you could maybe go through 5 examples or 10 examples and then assess how off you were and then adjust your form. This is important because you want to pace the learning of the model and make sure that it's learning as it sees more examples, again, not memorizing or not getting worse at its original goal. Now that's batches. If we move on to loss, which was that graph you saw with the squiggly line, we call that training loss, which you can pretty much translate to yourself as how much of our training understanding is being lost over time. If you have less and less lost, that's a good thing. If you're losing more of your training, that means you're pretty much not learning as you're seeing more examples. So continuing on with the basketball example, if you shoot and you get a complete air ball, it does not go in the net, that's bad. So training loss now is going up. You're not learning. Now if you hit the rim, it's not an air ball, it's not as bad, so your training loss starts going down, but not by a lot, because again, you're not getting the example perfectly right. But if you get a swish, you're now accomplishing the goal, you had the sample prompt, and you responded to it the exact way that your ideal answer would answer it, so the training loss starts to go down a lot. And ideally by the end of training, the graph looks like something from the very top left, trending all the way down. But like I said before, there is a limit to how low you want your training loss to be. If it's super low, like we're talking next to 0, that could tell you that your model has memorized these examples versus synthesized, digested, and actually generalized on them. And if it did memorize it, you'll be able to tell really quickly, because when you go and test a couple prompts, it'll seem like the model is completely funky, where it's not similar to the old GPT-4o that you used every day, and it's not really capturing the essence of your goal or the brand voice you're trying to emulate or the company values you're trying to instill, and it's all over the place. And just to drive the point home, if we take a sample example like this, write a newsletter about AI automation for business, and then our ideal answer is, oh, AI is the magic, swift, bright, etc., speeds your workflows day and night, so it's somewhat poetic. Let's say that's what we're going for. An example of it getting it wrong, where we kind of slap and training loss goes up, is it says something like AI automation can improve efficiency and reduce manual workload, which sounds very normal GPT, not tuned to the tone we're going for. So that would be bad. Good would be getting something like this. AI works while you take a rest, automates tasks, it does its best, no more stress, and it's being more poetic. And this is when the fine tuning would cause training loss to go down because we're learning. We have a changed behavior based on the same condition. Now there is one more element here that's called LR multiplier, which is called learning rate. Most times I would say I'd recommend you keep this as is. Learning rate multiplier is the pace at how fast the model's trying to change its weights in response to the examples you're showing it. So this is something you can tinker with if things are really not working with, but outside of really understanding the math underlying it, it's hard to simplify this in terms of like some form of heuristic on how you should change it. In general, this standard auto-created rate by OpenAI is a good one, so you shouldn't have to change it too much. And by default, again, you'll see my training loss here on my pretty simple data set worked pretty well. It is usually good at 3 epochs, 1 batch size, and around 1.8 LR multiplier. You keep those as is, and you're set to understanding how to do this now. Since we're all fine-tuning experts, I'll shift over to method 2, which uses a combination of Airtable and n8n. Before we go to the second example, I just wanted to quickly interrupt and remind you that if you are a business owner, business leader, or CEO, we've officially launched our early AI adopters community. We're almost at 50 business owners, and we're excited to welcome as many as possible. You get all kinds of benefits, including exclusive content, all the templates you'll see in this video without the Gumroad link, everything at your fingertips, as well as tons of coaching sessions and access to me. If that sounds interesting, check out the second link in the description below, and I'll see you in there. All right, back to the video. And this is the Airtable example. And while there are a few different moving parts here, we'll break it down step by step. In terms of the Airtable itself, all I have to do is say new run. You can name it whatever. This has no impact on the automation itself. And then we just create a field here in Airtable that allows you to upload files. So it's called an attachment column. So we save that. And then now when we click on here, it'll let us add an attachment. We can go on browse files and go into our fine tuning. We can take our original demo we used, upload that. And how this automation gets triggered in n8n is we have an automation in Airtable right here that basically says when the fine tuning column is checked, that it should send a webhook trigger to n8n. So if we were to click on this, start fine tuning, it would start. And what it's going to do is every few minutes, it's going to update us with the status of the actual training, because usually there's quite a few steps that happen behind the scenes before it's done. So it'll come back and say, hey, so it just validated the JSON files. The JSON files are validated. Okay, now it's halfway through training, because once in a while, fine tuning can take a while to run. Once it's done, we'll be able to also hands off see some test results where we send some sample prompts from our training set and we test to see how does the new fine-tuned model respond to it. So you can see here, this would be the test prompt that we send in a JSON, and then we get the response from the normal version of let's say GPT-4o, and then we get the fine-tuned response. So we can gauge the difference between this and this. So without actually going through the playground and having a conversation with it manually, we can tell almost instantly, is there a change in the way it responds? Last tab here is going to have the actual name of the model ID. So we can quickly go to n8n and test going back and forth with the model if we want to have a chat with it, which is why we created this flow right here, where all you have to do is just hook up a chat trigger to an agent module that calls OpenAI. And within OpenAI, you can just call your brand new ID and have a conversation with it right away just by clicking on chat and sending a message. Let's say, write me an email. Because it's all hosted in our OpenAI account related to our organization, it can actually have it back and forth to the model. So we're good to actually test it here. And if anything, it's easier than the playground, which can be annoying to use. And you can use this out of the box, and anyone on your team can actually test it or use it as well. Now, if we go back and tick that column, start fine tuning, it's going to start processing this file. And let's look at what's happening behind the scenes with the automation in n8n. So if we go into this workflow here, and it might look a bit daunting, it's actually pretty slick in what it's doing behind the scenes. So I'm just going to zoom in. So we have this webhook, which is being sent from Airtable, and you'll see here, it just kicked off the fine tuning. This receives that webhook, and then from Airtable, we download the JSON that we uploaded. We then upload the file to OpenAI because the fine-tuning aspect of it has an API we can talk to. And then it creates a fine-tuning job, which sends that feedback loop back to Airtable. So it tells it, hey, we just kicked things off. And then as things progress, it'll start saying things like we validated the training file, which it says right here, because it's getting that feedback and we're listening for those events from the fine-tuning API. Once we go into this loop here, what we're doing is we're just continually checking the job until it's done. So we're waiting around 30 seconds and then getting the latest report on how the fine-tuning is going so that we know if it's hanging, if it's having a problem, if it's having some issues with the uploading of the files, or if the files are not actually properly formatted. So once we go into this loop here, all we're doing is just endlessly looping through, updating until we get to the point where the fine-tuning is complete. Once the fine-tuning is complete here and the job finished is set to true, we then download our original JSON file because we want to grab, let's say, 3 different prompts from our training as well as the ideal answer and test it against the new model. So we'll then convert it to a string, convert it to a JSON, bundle them together, and then send those 3 prompts to normal OpenAI. Let's say if it's a 4.0 model or a 4.0 mini model, we'll send it there. Otherwise, we'll send it to our brand new model, and then we'll add it in the test results section of the Airtable that I showed you here. So if we go back to this section, we created another part of this base that's keeping track of our different runs. And by the time that this is done running, we'll have a brand new test set here where we'll be able to see those examples as well. If we go back to n8n one more time, I'll show you the last component here, which once finished adds the fine-tuned model to that last page to tell us what the ID is, and it updates the status of the job here. And what it should look like once it's done running, it should say finished, the name of the model, the monitor status should be pretty much complete, and then you can see here right now in our current phase, the files have been validated, so our JSON's good to go, and it's moving it to queue, meaning it's about to start the fine-tuning process. Depending on where you are in the world and your bandwidth, it might take between 15 to 30 minutes to do a fine-tune run, but once it's done, you'll get the feedback here. But one thing to be suspicious of is if you go into n8n and you go into executions and you see this latest run go for 1, 2, 3 hours, most likely there's some form of hanging issue in OpenAI, which is why I like to keep OpenAI open and I refresh during this process, because as soon as you kick off the fine tuning, you'll be able to monitor here as well. And if it is hanging a lot and you only have 50 examples in a JSONL file, this is typically either their API is having issues or you might need to cancel the job and rerun it. And once this stops running, you can theoretically create multiple fine-tuned models if you want to apply to different use cases in your organization where you want to start relying on prompts less and worrying less about prompt drift, which is pretty much where the same prompt will behave differently for new models, and you want to start depending on your own fine-tuned models with your own secret sauce. This is a really cool way that now is easier and more democratized for anyone to be able to use anytime. Now I'm going to make available the prompt I used to create the JSONL file in O3 Mini, the structure of the Airtable, the n8n automations, and everything you saw in this video in the Gumroad link in the description below. If you can support the channel, I appreciate it. And if you are a member of my early AI adopters community, it will be auto-synced in the community in the next couple hours, so you can use it right away. If this was helpful, let me know down in the comments below and let me know what you'd like to see next.